Okay, today we'll focus our attention on numerical integration, but before we start, here is one simple example. I would like you to find the, to evaluate
E
this,
minus 1.
which is, yes, thank you, e to the x, and then you'll have 0 to 1. So this is just an example. And that's going to give me e raised to power 1 minus e raised to power 0, which gives me e minus 1. Now let's try another one. 0 to 1 e x squared dx, for example. What is the integration of this? Think for a second and let me know. How can you do that? So this example 2, this cannot be evaluated that easily. Okay? There is no such formula which allow us to evaluate this integral. If you know exact value of this, then let me know. We can find the approximate value, but exact value, I don't know. And there is no such rule where you can apply and find the integration just like that. Okay, so in this case, what we do is, even though we are not able to find the exact value, the method that we did here in example 1, it is called analytical method. Okay, analytical method of finding the integration. It gives us the exact answer, exact value. So what it means is, suppose you have your graph is, let's say, this one, e to the x, and all we are trying to find is area from 0 to 1. So this is the area that we are trying to find, and we found it. The area is actually e minus 1. But in this case, we cannot find that. But what we can do is, we can draw the graph and find the approximate area. And you already know how to find the approximate area by using left endpoint, right endpoint, and midpoint. Those methods are called numerical methods of approximating the integral. Okay. So we already learned, like I said, we already learned a couple of methods to approximate the value of the integral by using left endpoint rectangle, right endpoint rectangle, and midpoint for the rectangle. But there are two other nice methods which gives even better approximation. And that's what we're going to learn today. Okay. So the idea is, generally, when the integral cannot be evaluated by using any method, we can find the approximate value by using the numerical method. And numerical method involves left and right endpoint, midpoint. And the two methods that we're going to learn is called the Trapezoid Rule and Simpsons Rule. Okay, Trapezoid Rule and Simpsons Rule. So here is the goal of today's lesson. So at the end of the lesson, you'll be able to use Trapezoid Rule to approximate integrals and use Simpsons Rule to approximate the integrals. These are the two main goals for today's lesson. Okay. So let us look at what is trapezoid rule. Here is the formula. And let us develop the formula quickly. So as you can see in this figure, I have a function. This is my function f of x. And I want to find integration a to b f of x dx. So that means this is my a here, as you can see, and this is my b, the last endpoint. So instead of dividing this into rectangle, today we're going to divide this into trapezium. Okay, trapezium. You know what is trapezium means. So trapezium means like this one and this one, two sides are parallel, and this kind of figure is called trapezium, right? We know that. So here what I did is a to b is divided into n partition. We call it partition, by the way. we divide them into n small parts, n partition, and now we're gonna do, we're gonna draw the trapezium. As you can see, I'm drawing all the trapezium. Okay, like this, and so on. Now, to approximate the area under the curve, what you can do is you sum of all of the area of all of the trapezium. So area of the first trapezium. Now let us look at what is the area of the first trapezium. So this is your x naught. Okay, so that means the height will be f of x naught, and this will be f of x1. This is f of x2, f of x3, and so on all the way. This is f of x. This is f of, this height is f of xn, and this height is f of xn minus 1, and so on. This is f of xn minus 2, and so on. Okay, now we divide this a to b into n trapezium, so the width of the trapezium is actually delta x. Okay, so that means delta x is b minus a divided by n, just like as we did in case of Riemann sum in the left endpoint, right endpoint method. So delta x we can find that way. Now let us find the area of the first trapezium. So area of the first trapezium is sum of the recall the formula from your high school geometry, sum of the parallel sides times the distance between these two parallel sides, which is dx. So I can write this as sum f of x naught plus f of x1 divided half times this times delta x. So that is this one is the area of the first trapezium. In the same manner, area of the second trapezium is given by this sum of the parallel sides divided by 2 times delta x, and all the way up to sum of the the last trapezium will have the area this. Okay, now let us calculate this a little bit. So here, if what I can write here is that, okay, let me just write it down here. So what we got here is delta x is common. I'll just write that delta x outside. So the remaining is half f of x naught plus half f of x1. Okay, this is the first one. Half f of x naught, half f of x1 from the first trapezium. Now in the second trapezium, plus half f of x1 plus half f of x2. That is for the second trapezium, as you can see here. In the same manner, for the third trapezium, it will be half f of x2 plus half f of x3. And it goes all the way, and let me go here, plus all the way. So the second last trapezium will be half f of x, okay, second last trapezium, this one, this trapezium is half f of x n minus 2 plus half f of x n minus 1. Now the last trapezium will be half f of x n minus 1 plus half f of x n. So this is the area of all the trapezium. Okay, now let us do a little bit of a calculation here. So notice that this half f of x naught combine the like terms. There is no such term, so we just copy that as it is. Plus this guy and this guy, you see like terms, half f of x1, half f of x1 will be simply x1. Half f of x2, half f of x2 will be simply x2. So it goes all the way up to f of x n minus 1, and but the last one is just by itself alone. So this is f of xn. Okay, so that is the formula. That is the area of all the trapezium. Now it's easy to remember the formula, by the way. So you see this little poor guy, the first one, it is half because it didn't find any pair, any partner there, right? When we are working there. So this poor guy, the first one, and this poor guy, the last one, they could not find any partner there. So they just have half, but every other here got the partner. So we combine them together, and so they do not have half. Okay, so this is the formula that you need to remember. And here is the formula that I have written. All right, so that's the formula. B minus A over N, you can write simply B minus A over N, or you can replace that by delta X because it's the same thing. We're going to use that formula. And another method is called Simpsons Rule. So in Simpsons Rule, what Simpson actually did is, instead of dividing this into trapezium, this guy tried dividing it into parabola. Okay, and so he came up with this formula. The proof of this formula is out of the scope of this course. So if you take higher math course in the future, probably you will prove there, but I'm going to provide the proof in my lecture note just in case if you are interested. But again, this is not required for this course. Okay, it is out of the scope of this course. So this is the formula that we'll be using to approximate the integral. And one thing though, you need to remember that in order to use the Simpsons rule, then the number n here must be even. If n is odd, we cannot use Simpsons rule. Keep that in mind. For trapezoid rule, it doesn't matter whether n is even or odd. For example, if n equals 5, we can use the trapezoid rule. We can use the left endpoint, right endpoint, midpoint, but we cannot use Simpsons rule. Okay, but because this is odd number. But if n is, let's say, 4, for example, which is even number, so we can use Simpsons rule, we can use Trapezium rule, we can use, left endpoint, right endpoint, midpoint, all of these rules we can use. So keep that in mind. Now let's try a couple of examples. In question 1 and 2, in question 1 and 2, in the following exercise, use the given value of n to approximate the value of the given integral by the following method: trapezoidal rule, Simpsons rule, and also find the exact value either by integration or by using geometry. And compare this result and tell me which of the following, which of the two approximation technique, trapezoid and Simpsons, is more accurate. Okay, that's the thing. Again, remember, generally, okay, in general, these numerical methods are used if there is no, formula that we can apply and evaluate the integral analytically. That's the idea. But in order to, show you that trapezoid rule and Simpsons rule actually gives pretty good approximation, I consider an integral that can be done analytically. Okay, just to see whether actually it gives the approximation or not, because we need to convince ourselves that this rule actually works, right? So for that reason, I choose a simple integral so that you can, use the trapezoid rule, you can use the Simpsons rule, and you can do this analytically, and you can compare the answer. Okay, so let's try. First thing first. Okay, first of all, try to figure out what is your A here, what is your B here, and what is your N here, and what is your delta X. So A is 1, B is 2, A is the lower limit, B is the upper limit, N is the number of trapezium or whatever that n is, in this case number of trapezium, and delta x is actually b minus a divided by n, which means 2 minus 1 divided by 4. That's going to give me 0 0.5. Oh, 25. 0 0.25. Okay, any questions so far? Now, with this, I think it will be a good idea to make a table, because if we calculate all the value in the table and later we can just plug in the value. So let us make a table here. Okay, first of all, xi here and f of xi. So remember here our f of x is, let me just write f of x as well. So f of x is actually x cubed. This is our function. Now, so my x naught equals 1. That's the starting. X naught means always a starting point. Okay, you can denote that by x naught, 1. So the function is x cube, so that means 1 cube, which is 1. Now your x1 will be always x naught plus delta x, because the idea is this: when you have x naught here, then this x1, this is the distance at a distance of delta x, so therefore x1 will be x naught plus delta x. And here is x2, so x2 is at a distance of delta x, so x2 will be x1 plus delta x. That's how we calculate these values. Okay, so that means x naught is x naught is 1 plus delta x is 0.25. I think I need a little bit more space here. Let me just use this. X naught is 1, x1 is x naught plus delta x, which is 1 plus 0.25, which is 1.25, and x2 is x1 plus delta x, which is 1.25 plus 1.25, which is 1.5. x3, you can calculate that, which is x2 plus delta x, which will be 1.75. Okay, x4 is x3 plus delta x equals, this will be 2. So now your function is x cubed, so x is 1, it will be 1 cube. This one is 1.25 cube, and I want you to calculate, this is 1.5 cube and 1.75 cube and 2 cube. I'll calculate that for you. Okay, so type your answer in the chat box. So 1.25 cube will be 1.95, and this one will be 3.38, and this is 5.36. That's what you wrote in the chat box. I'm just copying this, and I trust that this is the correct calculations. Okay, all right, so we got the table and we got all the value that we need. Now first, part A, let us use trapezoid rule. So the formula is integration a to b f of x dx. Just copy the formula, which is b minus a over n, or you can write simply delta x, and then half f of x naught plus f of x1 plus f of x2 plus f of x3, and the last one is f of x4, and this poor guy doesn't have the pair, it will be half. That's it, first and last. So substituting the value b minus a over n, we already calculated there, which is 0.25, and then half f of x1 x naught is, we have the formula here, f of x naught is actually 1. Okay, remember here this one is our f of x naught, this is our f of x1, f of x2, f of x3, f of x4. So we already calculated, and so plus f of x1 is 1.95, plus f of x2 is 3.38, plus 5.36, plus half times 8. So please calculate and let me know what is the total answer here, okay? So the answer here is approximately 3.8. To be precise, this is 3.79. What did you come up with? 7975. Okay, 7975. Okay, to be precise. All right. So I'm going to use this approximate sign here because the formula is, we get the approximate value for this integral. So I'm going to use the approximate sign there, but here I can write equal sign. So this one is the answer. This is the approximate answer for this integrals. Now let's try part B. So part B, we're going to use the Simpsons rule. So let me write down the formula first. So the formula is a to b f of x dx is approximately equal to b minus a. Look at the formula. So the formula here I have given you here, which is b minus a over 3n f of x naught plus 4 f of x1 plus 2 f of x2, and it just alternate 4 2 4 2 4 2 and then 4 and then the last one. Okay, so let me just copy the formula as it is. So b minus a over 3n, and so the formula is, the first one will be this, just f of x naught, plus second one is f of x1 plus f of x2, 4 2 2 f of x2 plus 4 f of x3, and the last one will have no coefficient, simply one coefficient, which will be f of x4. This is the formula. Okay, it's not difficult to remember, to memorize. B minus a over 3n. So in the previous formula we need 3n and f of x naught, and then 4 2 4 2 4 2 4 2 4, and then the last one will not have any numerical, there is just one coefficient. Every other will have 4 and 2. Now let us substitute the value. So b is 2 minus a is 1 divided by 3 times n is 4. F of x naught, we already know the value, which is 1. F of x naught is 1 plus 4. F of x1 is 1.95. 2 times 3.38 plus 4 times 5.36 plus last one is 8. And I need your help. Help me to find out what is this equal to. So this is 3.75. Part B is done. Now in part C, what we are supposed to do is find the exact value either by using the analytical method or by using the geometry. So here it's easy to use the exact method. Our goal is to find 1 to 2 x cubed, evaluate this integral. And so if you evaluate this integral, it's going to give you x power 4 over 4. And the lower limit is 1 to upper limit is 2. So then using the fundamental theorem of calculus, you're going to get 2 power 4 over 4 minus 1 power 4 over 4. And how much is that? Again, I need your help. Okay, this is also 3.75. That's what you come up with. Okay. Now part D. Part D. So part D, which of the method, trapezoid rule or Simpsons rule, which one gives the better approximation? And you can compare the result, right? So you see trapezium is this and Simpsons rule is this, 3.75. The exact value is also this. So that means in this case, Simpsons rule gives better approximation. So we are lucky that we got exactly the same value in case of analytical and Simpsons rule, but in general, that is not the case. They will be approximately the same, but you know, this is just a coincidence that we got exact same value. Okay, but anyway, we can say that Simpsons rule gives better approximation. Now the question is it just a coincidence that Simpsons rule is better approximation? It's not a coincidence. In general, okay, in general, Simpsons rule gives better approximation than trapezoid rule, than midpoint rule, than left endpoint, right endpoint rule. Keep that in mind. Let me repeat this. In general, Simpsons rule gives better approximation. Okay, is there any question? So example 2, first of all, what is given here? Here A is -2, B is 2, N is 8, and delta X is B minus A over N, which is 2 minus -2 over 8. I believe this is 0.5, right? And your f of x here is f of x is square root 4 minus x squared. And now I want you to draw a table and find the value for all of these xi, f of xi, which is square root 4 minus x squared. I'm going to do the first one. Xi means x naught. Start with x naught, which is actually a, which is -2. That's the starting point. And so you'll have f of -2 equals square root 4 minus -2 squared. That's going to give you 0. And in the same manner, your x1 is x naught plus delta x, so which is -2 plus 0.5. So that's going to give me -1.5. And so f of -1.5 equals square root 4 minus -1.5 square. And calculate this. I believe it will be, my calculator is telling me it is approximately 1.32289. So generally, you can take 4-digit after decimal is fine, but to be precise, I'm considering 5-digit, but you can actually take 4-digit, no problem. Okay, so that's your x1. In the same manner, x2, find x2, find x3, x4, x5, because n is 8, so you need to find all the way up to 8, x7 and x8, and you calculate that value. Okay, I'll divide you into groups, and you work as a group for these questions. Okay, so you did this in the breakout room together with your friend, and I have all of these here, the values, f of x naught, x1, f of x1, f of x2, all of these values are there. And for trapezoid rule, you know the formula, a to b f of x dx is approximately equal to b minus a over n. And then the formula is half f of x naught plus f of x1, f of x2, all the way up to f of x7 plus half f of x8. And just substitute the value and you're gonna get the answer to be, you already wrote the answer in the chat box. I'm gonna just copy that answer because all of you got the same answer. That means the answer must be correct because it is very difficult to get the same wrong answer. So it is 5.991. That is your approximate value for the integral using the trapezoid rule. For Simpsons rule, again, the formula, I just copy the formula and I plug in the value in the formula, and then you guys already got the answer, which is approximately 6.167. And I trust that this is the correct answer because so many of you got the exact same answer. All right, so I hope that, I trust that the calculation is correct. Now part C, using analytical method or using the geometry. So analytical method is a little bit difficult in this case because we have to use the trig substitution. So I think the easiest one would be the geometrical method, okay? Using geometrical method. Let me just do it quickly. I believe we have done similar questions in our earlier class. So using geometry, so here the function is given, y is given is square root 4 minus x squared, and then the a is a negative 2 to b is 2. So if you draw the graph, you're gonna get, this is your negative 2, this is your 2, and this is the function, right? So this is your function. That means we are trying to find this area, and which means integration negative 2 to 2 is square root 4 minus x squared dx actually means this is a semicircle. So pi r squared divided by 2. So which means pi r means 2 squared because the radius is 2 over 2. So that's going to give me 4 pi. Let me just write it down here, which is 4 pi, and which is approximately, you can calculate that by yourself. Now the last question, suppose that the marginal cost in hundreds of dollars per day of a company were as follows over a certain period. So years are given and the marginal cost are also given. Approximate the area using trapezoid rule and Simpsons rule. So let's try that. Starting with this, you know that this one is your x naught. This is your x1, x2, x3, x4, x5, and x sub 6. So that means, can you tell me in this problem what is your a? Because if you want to use the trapezoid rule and Simpsons rule, you need to know what is your a, what is your b, and what is your delta x. And function, well, if you want to do the analytical method, then you need function, you need to know. But in order to use the trapezoid rule and Simpsons rule, without knowing the function, we can also find it because the functional value is already given here. So f of x naught is given here, f of x1 is given, f of x2 is given all the way, f of x3, f of x4, 5, and f of x6. Okay, so a is, okay, you wrote that in the chat box. So a is your 1, b is 7, yes. This is the starting point is always a, the ending point is b. So delta x will be b minus a over n. So what is n, by the way? N is 6, okay, because the last one will be xn, so you can compare xn is x6, so that means n is 6. So you can calculate delta x is 7 minus 1 over 6, which is 1. Okay, now using the trapezoidal rule, your a to b f of x dx is going to be b minus a over n f of x naught plus f of x1. I want you to complete this by yourself, guys. Okay, there is half. Okay, instead of writing this integral, I just want to write the area here, because we don't know the function. Okay, f value is not given, so area approximately is given by, area represent the total cost function or profit, total cost function. So the total cost will be given by this, which is b is 7 minus 1 divided by 6, and then you just substitute the value here, half. F of x naught is 9 plus 9.2 plus 9.5 plus 9.5 plus 9.8 plus 10.1 plus half 10.5. And then if you work it out, let me know what is the answer. Okay, guys, I see your answer here in the chat box, and you got, all of you got 57.85. So I trust that that is the correct answer. So done. And part B, using the Simpsons rule. And first of all, can we use Simpsons rule here? In order to use Simpsons rule, n must be even. Is this even number? 6 is even number? Yes, it is even number. So yes, we can use it. And so according, using the Simpsons rule, area can be approximated b minus a divided by 3n, and write down the formula, which is f of x naught plus 4 f of x1 plus 2 f of x2 plus 4 f of x3 plus 2 f of x4 plus 4 f of x5 plus f of x6. Okay, just substitute the value and then let me know what is your answer. So after substituting the value, then you guys got the answer to be 57 point, let me see, 76. I can write 77 approximately, 57.77 approximately, and I trust that that is the right answer, and we're done. Now, a couple of things to remember here. Okay, let us recap. In general, we use numerical method if we cannot evaluate the integral by using the analytical method, okay, by using the other formula, exact method. And another thing to remember is that in order to use the Simpsons rule, n must be even. Another thing to remember here is that one of the advantages of numerical method is this. In example 3, if you want to calculate by using the exact method, the analytical method, you cannot, because the function is not known. Okay, but to use the trapezoid rule, Simpsons rule, or left endpoint, right endpoint, midpoint, even if we don't know the function, but if we know the functional value here, then we can use those method, numerical method, and find the area. Okay, so this is the advantage of using the numerical method. Even though we will get approximate value, but we are able to find the area, okay, even though the function is not given. All right, so this section is done.